The first drones weren't built for photography, farming, or construction. They were built for war. And what happened next completely changed how we use them today. If you walk up to 10 people and ask them when drones were invented, you'll probably get the same answer over and over again. Well, recently, or like in the last 10 years, or whenever DJI showed up. And that's probably because drones feel new. They look new, they move very smoothly, they have cameras, GPS, obstacle avoidance, AI features, all the things that we associate with modern technology. But here's what surprises most people. Drones actually didn't show up recently. They didn't suddenly appear when cameras got smaller, and they definitely didn't start as toys or photography tools. The story of drones actually goes back more than 100 years. And once you understand the history, why drones were created, how they evolved, and what problems they were meant to solve, you start to see drones very differently. Not as gadgets, not as trends, but as tools that evolved because people kept asking one important question. How can we do this better and safer? Let's rewind back, way before airplanes, before computers, before remote controls as we know them. In the 1800s, the idea of unmanned flight had already existed. People were experimenting with balloons that could float without a human on board. Some were used for weather observation, some were used to carry messages, and some were even used, unsuccessfully, for early military purposes. Now, none of this was very precise and none of it was reliable, but it introduced a powerful idea. Flight doesn't require a pilot. And that idea is the root of everything that comes next. One of the most important early moments happened in 1898 when Nikola Tesla demonstrated a radio-controlled boat. Now, this wasn't a drone technically. It didn't fly like we're thinking of the drones today, but it proved something revolutionary for its time. Machines could be controlled remotely by a human operator. That concept, separating the operator from the machine, is the backbone of modern drone operations. Now, at this point, the technology just wasn't quite ready yet. The engines were heavy, the radios were unreliable, there were no onboard computers, but the idea was there. And once an idea exists, it has a way of resurfacing when the technology catches up. Like many major technologies, drones took a leap forward during wartime. During World War I, aviation itself was still pretty new. Pilots were flying open cockpit planes made of wood and fabric. Flight was dangerous. The navigation systems were really primitive. So engineers and military planners started asking, what if we could send an aircraft somewhere without risking a pilot's life? That question led to early unmanned aircraft concepts, including the Kettering bug. The Kettering bug was designed to, number one, fly a preset distance, then shut off its engine and crash into a target. By modern standards, it sounded pretty low tech, right? And it was. But the concept was groundbreaking for the time. It introduced the idea of a pre-programmed flight, a machine following instructions without a human on board. And even though these early systems were not widely deployed, they proved something very important, that unmanned aircraft were possible. And once something is possible, people will keep improving it. So after World War I, the focus shifted away from the experimental weapons and towards training. Militaries needed a way to train anti-aircraft gunners without risking a pilot's life, destroying expensive planes, or using unrealistic simulations, and that led to radio-controlled target aircraft. One of the most famous examples was the Queen Bee, which was developed by the British Royal Navy in the 1930s. These aircraft were flown remotely and used as moving targets for military exercises. And here's a small detail that stuck. Because the aircraft was called the Queen Bee, the unmanned aircraft flying alongside it started being referred to as drones, like the drone bees that are found in bee colonies. The nickname drone ended up sticking, and it's been used to describe unmanned aircraft ever since. World War II pushed aviation technology forward at an incredible pace. Jet engines, radar, mass production, everything accelerated. And drones also benefited from that momentum. In the United States, the radio plane OQ-2 became the first mass-produced unmanned aircraft. Thousands of them were built. They weren't used in combat missions. They were actually primarily being used for training. But these training mission drones mattered more than people realized. They proved three things. Number one, that drones could actually be manufactured at scale. Number two, that drones could be reused. And number three, that drones could be integrated into real operations. Now, at this point, drones were no longer just experiments. They were real tools that people were using. And then after World War II, global conflict changed. The Cold War wasn't about massive battles like World War I and World War II were. It was more about intelligence and surveillance and information. And that's where drones found their next major role. Reconnaissance drones, like the Ryan Firebee, were developed to collect imagery over hostile and restricted areas. They're basically spy drones. These drones could fly long distances. They could capture photographic data, and they could return all without risking a pilot. And that was a major shift. Drones weren't just aircraft anymore. They were like flying data collectors. And this concept of data collection is incredibly important because it's the same role drones play today in construction, agriculture, engineering, and public safety. Different sensors and different software, but the same purpose. And we're going to talk more about that in just a second. So at this point, you might be wondering, drones have been around so long, why didn't we see them everywhere sooner? Well, the answer is simple. The technology just wasn't ready yet. For most of the 20th century, drones were really large, expensive, complex to operate, and they required trained operators and special infrastructure and significant budgets. That limited drones to really the military and government use. But everything changed when three technologies matured all at the same time. Computers got smaller and more powerful, GPS finally became widely available, and then cameras became very lightweight and affordable. That combination of booming technology changed everything. By the late 1990s and early 2000s, drones entered what many people think of as the modern era. Aircraft like the MQ-1 Predator and later the MQ-9 Reaper introduced capabilities that were unheard of just decades earlier. They could stay airborne for long periods of time. They could stream live video back to command centers, and they could be controlled from thousands of miles away. These drones demonstrated what happens when unmanned aircraft are paired with GPS, satellite communication, advanced sensors, and onboard computing. And these major shifts in technology didn't just benefit the military. Consumers also started to realize the vast opportunities that drones provided. The true explosion of drone use didn't happen on military bases. It happened when drones became widely accessible to the public. In the early 2010s, companies like DJI introduced consumer-friendly drones like the DJI Phantom. These drones changed everything. So for the first time, we finally had drones that were affordable, portable. They were easy to fly. You didn't need a runway, you didn't need a team, and you didn't need years of training. And most importantly, for industries like construction and engineering and agriculture, you could collect usable, important data with drones. This is the moment that drones stopped being a niche technology and became a major platform for professionals in so many fields. Once drones became reliable and affordable, industry started experimenting. Construction teams realized that drones could document job sites and measure big volumes of materials and track progress. Then farmers realized that drones could identify crop stress and monitor irrigation and improve their overall efficiency and management of their crop. Public safety agencies realized that drones could search areas faster to find suspects and reduce risk to first responders. Also provides situational awareness. Engineers realized that drones could collect data that used to take days or weeks to do, now done in just a few minutes or a few hours. And these are just a few examples of how drones are having a huge effect on people's careers. This is where the story really connects to education. Drones are one of the few technologies that naturally combine science, technology, engineering, math, but they also teach problem solving, data interpretation, and systems thinking. So when students learn about drones, they're not just learning how to fly, they're learning how hardware and software interact, how data turns into decisions, and then how technology can help solve real-world problems. That's why drone education isn't just about a hobby or flying fun toys. It is about skills. Today, drones are continuing to evolve more and more. We're seeing increase in automation, AI-powered analysis, beyond visual line of sight operations, and then integration with digital twins and smart infrastructure. Drones are becoming data platforms, not just simple flying cameras. And the students learning drones today aren't preparing for some distant future. They're preparing for jobs that exist right now and jobs that are growing fast. So when you look at a drone today, you're not looking at some type of brand new invention that just came out. You are looking at over a century of ideas and innovation. A long line of people asking, how do we do this better? How do we make this safer? How do we get better information? Those questions built drones. And it's the same question students will keep answering as this technology continues to evolve.